So thank you all for being here today. I'll be presenting some of Root's newest Pythonizations, including UHI, RDataFrame, and more. So today, Python is widely used in high-energy physics analysis workflows. And as the scientific Python ecosystem evolves, Root also evolves towards a Pythonic user experience to align more with the community's needs and expectations. And we do that by focusing on three main aspects: interoperability and integration with existing Python packages, usability through a Pythonic natural interface, and a distribution that is standardized. And in today's talk, I will be covering one example of each of these aspects, starting with interoperability. And a great example of that is Root's recent adoption of the Unified Histogram Interface. The UHI is a specification that is meant to unify histogram operations across different Python libraries. And Root adopted the UHI in version 6.36, effectively connecting it to the broader Python ecosystem, as you can see on this plot here. Concretely, UHI introduces NumPy-like indexing for root histograms, which means that you can perform the same operations with an alternative syntax, including bin setting, accessing, projections. And on top of that, you unlock some new features that would not have a direct translation in Root, like slicing. I've also listed a couple one-liners here on the right, which are not trivial to express. So before, these were multiple lines and verbose, and now they are expressive, intuitive, and Pythonic. And plotting is just as seamless. To demonstrate that, I grabbed an existing Python, an existing Root tutorial, and I translated it UHI style. So if you scan the QR code, you can have access to the full code. But for now, I want you to focus on the little snippet I have here on the right, in which you can see that there is no conversions, no extra steps. You can directly plot root histograms with any UHI compatible library. The UHI implementation is extensively tested in Root, and we continuously get user feedback to improve and tackle edge cases. And on top of that, we have also recently adopted the latest UHI testing helper. This is a common set of cross-library validation tests that is meant to ensure consistent behavior across all UHI adopters. And of course, root histograms pass all the tests. Moving on to the second aspect, which is usability. On this side, our goal is pretty simple, is to enable fully Pythonic analysis with Root. And this goes through multiple components of the framework, but today I will show one of the latest advancements in the RDataFrame Pythonic API. To demonstrate this, I have this little snippet here on the right, where you can see that I'm defining a Python function inside which I perform Pythonic operations using NumPy, for example. I can then use this function directly to define an RDataFrame column. And this works by using Numba to JIT compile this Python function and then run it directly inside of the RDataFrame event loop. The table here on the right demonstrates the level of support that we have today. So this function that I'm defining here can take as input arguments and return outputs of fundamental types, some C++ containers, namely root argvex, stud vectors, and pseudoarrays, NumPy arrays, a limited set of root classes, and this is limited by the CPPYY Numba extension, CPPYY being our dynamic Python C++ bindings generator. For awkward arrays, there is a bit more to it. Interoperability is there in a sense that if you have awkward arrays, you can write them as RDataFrame columns using awkward conversion functions like to RDataFrames. You now have these RDataFrame columns of type root argvex, which were originally awkward arrays, that you can manipulate using a Numba-JIT function like this one. What you cannot do is call any of awkward's vectorized functions, so anything that is awkward or something, but you're not meant to anyway. Moving on to the last aspect, distribution. To make the Python experience even smoother, we have increased the effort into distributing root through commonly used Python packaging systems. And we do this through conda and pip. On the conda side, the system is already in production. All root releases are now published on CondaForge and available for Linux and Mac OS. You can try it yourself, conda install root. On the pip side, we have first presented last year at CHEP, the first ever Python wheels that were produced for the root project. And since then, we have been working on streamlining the production of these wheels, which are currently built nightly by our CI for Linux 886. And our aim is to release the next version of root, which is 638, as the first version available on PyPI. But you don't have to wait until then, because as of last week, you can actually try it yourself simply by pip install root. Moving on to the conclusion, I have covered one example of each of the axes I mentioned earlier of root's Pythonization efforts, including interoperability through the UHI implementation, usability through RDataFrame's Pythonic API, and distribution through conda and pip. But this list is by no means exhaustive. There's way many more efforts ongoing across root to make it feel natural and expressive in the Python ecosystem. Thank you very much for listening. If you have any questions, let me know.